Welcome! Today, we're diving deep into the rulebook for building absolute giants. We're talking about those massive industrial tanks. We're pulling straight from the industry standard, API 650, to show you the super strict rules that make sure these things are built right from the very first piece of steel.
Right? I mean, think about it. Building something this huge that absolutely cannot fail, that's a huge responsibility. The secret isn't just about using strong steel. No, it's about a super meticulous process where every single cut, every bend, even the chalk marks on the plate are all governed by a set of rules. It's all about locking in safety and integrity from day one.
Okay, so here's our game plan for this. First, we're going to cover the fundamental rules of workmanship. Then, we'll get into how the actual steel plates are prepped. After that, we'll look over the shoulder of the inspector to see what's on their checklist. And finally, we'll find out what happens when things aren't quite perfect.
First things first, let's lay down the law. Before anyone even touches a piece of steel, there are basically 3 core commandments that everyone in the workshop has to live by. You can think of these as setting the standard for everything that follows.
So what this really means is no shortcuts, ever. All the work has to be first class, period. And check this out. You can't just take a torch to a warped plate to straighten it out. Why? Because that heat fundamentally messes with the steel's strength. Even the crayons they use for marking have rules. They can't have things like sulfur in them that could contaminate a weld down the line. Every single detail matters.
All right, with those ground rules set, let's talk about the steel itself. You start with these huge flat plates. So how do you turn those into the perfectly curved, precisely engineered pieces you need to build a giant cylinder?
Well, it all starts at the edge. You have to have a perfectly clean edge to get a strong weld. One way to do that is called shearing. You can kind of think of it like a giant pair of industrial scissors, but it's only allowed on the thinner plates. For the really thick stuff, you have to use more precise methods like machining or plasma cutting to get that perfect surface ready for welding.
Now, here's a really important question that comes up all the time. Do you have to bend the plates into a curve back at the workshop, or can you just kind of pull them into shape when you get to the job site? The standard is super clear about this, and the answer really just depends on 2 things: how big the tank is and how thick the steel is.
And here it is, the answer, straight from the standard in Figure 6.1. This chart makes it really simple. Along the bottom, you've got the tank diameter, and up the side, you've got the plate thickness. That diagonal line cutting across the middle, that's the magic line that tells you if you have to pre-shape the plate or not.
So let's make this real. Imagine you're building a tank that's, say, 18 meters wide, which is about 60 feet. Looking at the chart, any steel plate you use that's thicker than 13 millimeters, that's half an inch, must be bent into shape before it's installed. And why is that so important? Because if you try to force a thick, flat plate into a curve on site, you introduce a ton of stress into the steel, and that can lead to failure. Pre-shaping it just ensures a perfect, stress-free fit.
Okay, so you've got all these super precise rules for how to work and how to prep the material, but who's actually making sure people are following them? Well, that's where the purchaser's inspector comes in. They are the ultimate guardian of quality on the factory floor.
And the API standard gives this inspector some serious authority. I mean, they can walk into any part of the workshop anytime they want. The manufacturer has to give them space and tools to do their job. They can pull material samples for testing whenever they feel like it. And, most importantly, they have the ultimate power to reject any piece of work that isn't up to snuff.
And this quote from the code, well, it says it all, doesn't it? The language is crystal clear. If the material or the work fails to meet the requirements, it can be rejected. Full stop. This one sentence is basically the safety net that guarantees the final tank is built correctly.
So, what happens when that inspector, making their rounds, actually finds a problem? I mean, steel isn't always perfect. Sometimes it has these internal flaws from when it was made, called laminations. How do you deal with those?
So the whole process kicks off with a really simple but critical first step, a visual check of every single plate edge. Now, if they spot what looks like a lamination, which is basically a separation inside the steel, that's not the end of the road. The next step is to bring in an ultrasonic scanner to map out exactly how big and how deep that flaw really is.
And here's the key takeaway. What you do next is all about size. If it's a small lamination, less than 75 millimeters, it can usually be repaired. You basically gouge it out and re-weld it, but you have to get the purchaser's permission first. But for anything bigger, the manufacturer has a really tough choice. Either scrap that entire very expensive plate of steel, or come up with a major complex repair plan that, again, has to be approved. You see, following all these fabrication rules makes sure that every single piece of the puzzle is perfect. But that's just the beginning, isn't it? The real test is still to come. What happens when all these perfectly made plates are finally welded together, and you fill this massive structure for the very first time? That is when you find out if all these rules really worked.